Okay, changing more to vectors. If I have vectors that look like this, or I can pull the s outside, I have vectors that look like 1, 3, 2 times a constant, where s is some real number. Are vectors of this form a subspace? So let's check to see if there is a zero vector. Yes, I can let s equal 0, and that gives me 0, 0, 0. So check, there is a zero vector. So is it closed under addition? So if I have s times 1, 3, 2, and I add t times 1, 3, 2, I get s plus t times 1, 3, 2, and that is in the subspace. So it is closed under addition. All right. The third criteria is if I take a vector that's in the set and I multiply it by c, so I have c times s, 1, 3, 2, 1, 3, 2, cs could be a new constant, 1, 3, 2, so this is in the subspace. So it is closed under scalar multiplication. Closed under scalar multiplication. So therefore this is a subspace. All right, so let's make it, just jump it up a notch here. So now I have vectors that have this form, so I have two different variables. So this st0 can be written as s times 1, 0, 0 plus t times 0, 1, 0, right? Because this s would go here, give me this s, and this t would go here, and then there's zeros in on the third entry here. Okay, so I'm looking at vectors that have this form. So is this going to be a subspace? So first, is there a zero vector? If I let s and t equal 0, yes, I get the zero vector. So that's all taken care of. Is it closed under addition? So if I have two things, so I'm going to use s1 times, well, let me just put it together. I don't have to separate it. I could separate it, right? This is an option to separate it into two, right? But I could use the vectors like this. So I'm going to use s1, t1, 0 plus s2, t2, 0. And because I know how to add vectors together, this gives me s1 plus s2, t1 plus t2, and 0. This is in the subspace. So this is closed, subspace, closed under addition. All right, so let's look at multiplying by a constant. If I take a constant times s, t, and 0, that's the same as saying cs, ct, and 0. This is in the subspace. So this is closed under scalar multiplication. So therefore, this is a subspace. All right, so then a question here, talking about this one up here, would this be a subspace of R2 or R3? So since I'm looking at S, T, and 0, some people might be tempted to say it's R2 because there's just two entries that have numbers in it, but that is not correct. It is a subspace of R3 because there's 3 entries. All right, so in other words, another way of asking this question, is R2 a subspace of R3? So is this a subspace of this? Well, I can see how they're related a bit, but they are not, right? Because I can't add things like that are in R2 to get to things that are in R3. So it is not. They are different animals, right? I'm going to use that phrase a lot. So different animals meaning no, I can't add ST and AB to get to things that look like CDE, right? It can't be done. So R2 and R3 have nothing to do with each other.